Hi, I'm Leela.
And I'm Nasir, and this is our science fair demo project, the Magic Mason Jar. And this experiment is a simple experiment about cohesion, adhesion, surface tension,
And polarity.
Yeah.
All you need is a mason jar, a plastic sheet, and water.
Now, as you see here, we have two normal mason jars with the lid, but it's a space here to pour the water. And what we're gonna do, we're just gonna take a gallon of water and we're gonna pour it in just enough to fill it up. It doesn't have to be all the way to the rim, but close enough.
Close enough.
Just like that. Now, what do you think is gonna happen if we were to flip this over?
I think it's gonna all spill out because of gravity.
I mean, that makes sense, yeah. Now, what do you think would happen if I were to put this card on top and then flip it over?
I think it would still fall because of gravity.
Well, I'm going to teach you about a little thing called friction and surface tension. This friction is the resistance between two surfaces, while surface tension is the cohesive force that causes a liquid surface to act like a stretched elastic sheet. So if I was to flip this over, a little bit of water spills out, but not all of it, and remove my hand.
Oh, it sticks.
It sticks like glue. I'm just going to flip this back over. Now, I want you to try the same thing. And it should happen the same.
Let's take mine.
Apply a little pressure.
Flip it over.
Remove your hand and
3, 2, 1.
it sticks. Now, that is an example of surface tension and friction. Now, what do you think would happen if I was to remove the sheet?
I think it's gonna spill out, of course.
I don't think so. And here's why.
Cut this part of the video out.
And if we remove, the water stays. Now, if you want to go under here, just carefully, I go over her head.
Not a drop.
Not a drop. Oh, it's okay.
Not
It's
a
on the
drop.
rim.
On
But
me.
if you tap, the second that I
Break the surface tension.
water comes out, which is so crazy. Now, if Leela does the same thing, let's see if it happens twice. Maybe she's
Let's
luck.
see if mine's
Or
special.
magic.
Okay. We got it sticking.
Got it stick and remove. Oh, why is that? Let's dive in. So to start, there's a little tiny screen on top of this cup. This is what helps surface tension and friction. Above the cup is allowing the water to stay in because water is a
Polar molecule.
which means it sticks together. As you can see in this model here, this represents water because it is sticking together. Kind of have similar how if you were to take a straw into a cup of water and blow bubbles, it would begin to make bubbles at the top and they would stick together.
When water sticks together, that is called cohesion. Now imagine this is a water molecule. Water will always stick to water no matter what. That's what helps the water stay at the top, the bottom of the mason jar is cohesion.
Now, cohesion is when a molecule of the substance, water molecules are attracted to each other, which is why water forms droplets instead of spreading out completely flat.
Like condensation.
Yes. Now, adhesion is the force that causes molecules of different substances to stick together, such as oil, like water clinging to a glass surface. As you can see here, there's a little bit of adhesion around this cup and in the inside. Now, a polar molecule has both a positive and a negative charge. And that's something that sticks together like such. And
Similar to like a magnet with north and south poles or a positive and negative charge.
yeah, and a non-polar molecule would be something that like has two negatives, like
Yeah.
you're trying to attach them. They wouldn't attach.
They'll have that
An
force
example of
pushing
it
them apart.
would be something like oil. Oil only sticks to itself.
Mm-hmm.
As you can see in this cup, there's just a little bit of oil. And I'm going to show you guys some more examples of water polarity with these few other experiments.
So we move this stuff aside.
This is our lava lamp experiment. And in here we both have a little bit of oil in both tubes here. And they're almost full, but not full. And we have a little bit of normal water here, just with a little bit of blue food dye so that you can tell the difference between the two. So This experiment, you need that, and then also an Alka-Seltzer. Oops. Alka-Seltzer is what's gonna make this experiment look fantastic. Now, if I took this picture and poured this water on top,
And we know the
all the oil
sits on top of water automatically.
because it is what? Denser than water.
Definitely.
And if I put this Alka-Seltzer in here, what do you think will happen?
I think it'll make it fizz up, maybe.
So you can see it falls down. It begins to send slight bubbles up to the top as it.
Oh, that's cool.
Similar to a lava lamp. Now, if you pour it in yours, this is a smaller version. All of the oil goes to the top. I'll take this Alka-Seltzer.
Mm-hmm. Let my water kind of get to the bottom a tad bit.
And we drop it in, and it begins to bubble.
And as you all can see, it kind of has like that lava lamp effect. The longer it sits, the more the bubbles will come up and, do the effect.
The water will begin to seep through the oil and rise up due to the Alka-Seltzer. Now, another example of water polarity would be our Ziploc bag experiment, showing how water continues to stick together and build that friction and surface tension. And with this experiment, I'm going to have Leela hold it. Nice and firm. It's a little heavy. It's filled with just normal water as well and orange dye so that it is easily visible. Now, this is just these are just a couple sharpened pencils.
Mm-hmm.
And if I take a pencil and just, oh,
I think you did it too hard. Oh no.
did it?
Yeah, it's
Okay. Let's try again. No water. Turn around.
If you ever try this, push them through a bit more gently, especially if the bag is very full.
A little water comes out from the back, and it is looking like a linear flow. Because it is straight. And we're going to try this experiment one more time to make sure we do it right. We're going to take another Ziploc bag. I'm just going to fill it up with a little water. This time we're going to have Leela add any color food dye of your choice.
Ooh, let's do pink. Or I guess red. 1, 2, 3.
And we're just going to close it. It made like a nice violet color.
It did make a really pretty violet.
I'm going to mix this up. I'm going to close it off at the top. Now she stabs the pencil through a little more gentle than me. It should. Put the water over here. It should just stay in. As you can see, the pencils are through on both sides and no water comes out.
Nope.
The water molecules do stick together, and this is a great example of surface tension,
And water polarity.
cohesion, adhesion, and more. Thank you guys for watching us demonstrate our
Experiments.
models of cohesion, adhesion. As you can see here, there is a little bit of a mess. That's about it.
Thank you.
Ugh.